Hello everyone, I welcome you to this tutorial wherein we'll be discussing about power consumption in wireless sensor node or network. So basically here, these sensor node performs two different role. One is they act like data router, and the other thing is they also act like data aggregator. So these are the two roles that which a node performs. So first is data originator, the other one is data router. And here power can be consumed in three main activities. One is sensing, processing and communication. And out of these three, we can compare these three activity like this. So where this is a chart that which is plotted between uh, the power consumption by different activities versus like the power against the power in milliwatt for Mika Z kind of hardware node. So here for sensing activity it consumes very less power, followed by for microcontroller unit it consumes somewhere around nearer to 30 milliwatt, and as you can see it's quite evident that the radio activity that which involves transmission, reception and idle listening consumes most of the power, and back in sleep mode it consumes the least power. So this is about the radio modules, and it's clearly evident that the communication activity out of sensing and processing communication activity consumes lot of battery juice. So a wireless sensor node can only be equipped with a limited power, that is lesser than zero point 0.5 ampere hour and 1.2 volt. Replenishment of power resource is impossible. So replenishment means restoring of something that to its previous condition. So in most of the cases, because wireless sensor nodes will be deployed in fields, their recharging of the battery is almost impossible. Wireless sensor network lifetime therefore shows a strong dependency on battery lifetime. So ampere hour is the amount of current with the time taken for a battery to completely discharge. In wireless sensor network, each node plays two different and complementary roles. One is data originator and the other one is data router. Power consumption can hence be divided into three main domains: sensing, communication and data processing. So here for sensing, sporadic sensing might consume less power than constant event monitoring. So here we can model this P as directly proportional to sampling frequency into e to the power ENOB, where ENOB is effective number of bits used. So this is the power dissipated by an ADC. So complexity of event detection, ambient noise levels and sensor type determine the sensing power. Next is data processing. In data processing, computation requires much less energy compared to that of data communication. A sensor node has built-in computational abilities. Energy consumption of the data processing has two terms here. One is the transistor switching. This first component indicates the transistor switching, and the second component over here indicates power loss due to the leakage current. So here these two can be interlinked, as you can see here, for due to energy spent due to the transistor, it's given as N into C into Vd square, and in the second term here we have again N but by divided by F, then here we have Vdd square, here we have just Vdd, and then here C can be equated, in place of C here we have leakage current I naught into e to the power Vd divided by N Vt, where N is number of clock cycles per task and C is total switching capacitance and Vdd is the supply voltage. And this N is constant related to the processor hardware, and Vt is threshold voltage, and F is the clock frequency. And finally, we have this communication, and this is the one that which consumes a lot of power. Communication is performed through transceiver circuitry during both receiving and transmitting data. Significant amount of energy can be saved by turning off the transceiver to sleep state whenever the sensor node does not need to transmit or receive any data. Power consumption for data communication PC is a combination of power consumed by these components. So that is, this results in equation PC is in turn equal to output power transceiver power. So this is PTX, this is PRX. So this is the output power transmitted, and PTX and PRX are the power consumed in transmitter and receiver electronics. So this is about the power consumption in wireless sensor network. And in our next video, let's go through simplified energy model.